Are you driving your audio system in the wrong gear? That's what we're going to be talking about in today's video. Hey folks, I'm Gene Delasella with AudioHawks. We are here with John Siau from Benchmark Media Systems. How you doing, John?
Very good, Gene.
So this is an interesting topic. We're basically talking about gain matching between your source and your amplifiers. And this is something that I've always played around with and wrestled with on the bench when I'm testing gear. I'm glad that you're covering this topic and you actually have a workbench to show us results, because there's people that have preamps and power amps and there's different gain settings on them and they're not sure how to set them to get the best signal to noise ratio, the lowest distortion. But you're actually talking about getting also the best power delivery. So that's a new dimension to this that I'm happy to explore with you.
Yeah, really trying to get the best signal to noise ratio. There's no shift lever on any of these products, but there's all these volume controls. And these days we've got volume controls on our media players, we get volume controls on our DACs, we get volume controls on our preamplifiers, we might have gain switches on our power amplifiers. Where do we set these things? What happens if we don't set them right? What do we need to do to get the best performance? And so we're going to actually look at some numbers. We're actually going to measure this system end to end. We're going to put a signal into the DAC. We're going to measure the signal to noise ratio coming out of the power amplifier. We're going to insert a preamplifier, and we're going to see what happens when we hook these things up right, and we're going to see what happens when we set things wrong. And how bad does it get? How good does it get?
And this kind of ties into the last stream we did on intersample clipping. If you have a DAC that doesn't handle the intersample peaks, 0 dBFS and above, you'll get higher distortion. And then there's fixes for DACs like that, like using JRiver to lower the digital signal to prevent some of that. And of course, if you design the headroom in the DAC, you don't have to worry about it like you guys do with your products. So this kind of relates to that. And I do encourage people to look at that other live stream that we did, and I'll link it up in the video description as well. So let's get into this. I'm going to basically zoom in so we can see your screen better.
Okay. And one of the things that makes this more complicated is we have RCA outputs that have a 2-volt RMS output. We've got a noise floor and we've got a 2-volt signal. We've got 4-volt XLR outputs, which are typical consumer grade XLR outputs. And then there's professional XLR outputs like we have on our products, which are 12.28 volts RMS. So the higher the signal gets, the further away you are from the noise, and potentially the better signal to noise ratio that you can get in a channel. But we've got this mix of products. You may have some consumer grade products in your system. You may have some unbalanced outputs. Trying to put all these things together and do so with what we call proper gain staging. So that's what this topic is about. It's about achieving proper gain staging between each of our devices in our system.
And yeah, so, would you agree with me that you want to do most of your voltage gain at the preamp level, not at the amplifier level? That's really
what we're talking about. You want to take your gain as early in the system as possible. So the sooner I go to a high level signal, the better I am going through the system. And so I'll have the best signal to noise ratio when I boost the signal in the beginning and take as little gain as possible in the power amplifier. And we'll actually demonstrate that, because I'll be able to switch this power amplifier into 3 different gain settings. Its low gain setting is very low. It's only 9 dB of gain. And if you look at a lot of power amplifiers, you'll find that they've got 25 dB of gain. They've got 30 dB of gain. You see 35 dB of gain. It's kind of like, oh, I got more gain than you. My amp's got more gain than your amp. Well, it's not desirable to have high gain in a power amplifier. What we want is a high signal level coming out of our DAC, a high signal level flowing through our preamplifier and a high level going into our power amplifier and doing a very small boost to get up to speaker level.
Yeah, you want your current gain in your amplifier
That's
more than
current.
anything.
You want
Yep.
current gain, but you don't want a lot of voltage gain.
Sure.
And so we see a lot of systems that are just plain built wrong, built backwards. You know, it's like a horsepower competition. How much gain can we have? When really, what we're concerned about is how much power do we have, and how much signal to noise ratio do we have. So let me explain the setup here. I have a benchmark DAC3. This DAC3 is a DAC3L, which has a volume control built in. I have a benchmark LA4 preamplifier, which is our relay gain control preamplifier. It has a 256-step fully balanced relay gain control. It will give you cut and up to 15 dB of boost. Right now you can see it's on minus 2 dB of gain. It's currently bypassed. I'm going directly from the DAC to the power amplifier. And power amplifier is a benchmark AHB2 power amplifier. This power amplifier delivers 132 dB signal to noise ratio in stereo mode, and it delivers 135 dB signal to noise ratio in bridged mono. And you're actually going to see that 132 dB number when we're doing the stereo test here. If you go to the background screen there, I'll explain what we have. These are various meters and displays from the Audio Precision. This is a scope output, shows the 1 kilohertz test tone that we're putting into the system, and it's coming out of the power amplifier. This is a power meter here. It's showing that right now I have 1 watt coming out. That's exactly 20 dB below the maximum output of the amplifier at its rated 100 watt output. So I'm running right now 20 dB below full output. This meter down here is dB relative to 1 watt. Because I'm at 1 watt, I'm 0 dB relative to 1 watt. If I was putting out 100 watts, I'd be 20 dB watts. Yeah. Okay. And over here, I have an FFT, which is a frequency display. I got 20 kilohertz here. I've got 0 hertz down here. This vertical line is my 1 kilohertz tone. You can see it's 20 dB below full output right now.
Yeah. Yep.
And over here, and this is going to be important when we're talking about how audible is the noise. If we have a set of 90 dB SPL speakers, the output at the right now would be 89 dB SPL. So with 1 watt going in, it's 90 dB SPL coming out.
Yeah.
Okay. If I have a set of horns that have high efficiency drivers, let's say they've got an efficiency of 100 dB, you can see I've got my 100 dB coming out with 1 watt going in.
At 1 meter, yeah.
At 1 meter. And it turns out that in a listening room with 2 speakers and typical listening distance and typical room response, that number is going to be really close to what you hear at your listening position. So it's a great
because you got room gain and you got multiple sources producing
exactly
uncorrelated sound, but still it adds to the SPL.
Yeah. And so that number will be very close. And so it's a great rule of thumb that whatever that noise calculation gives you at 1 meter in an anechoic space is going to be very close to what you're going to get from a stereo system at your listening position. So that's the setup. Over here, I've got the AHB2 test system. Yep. And behind me, I've got an oscilloscope that is showing the output waveform from the power amplifier.
So, John, I got to commend you guys because people may not realize this. When you're looking at all this audio precision gear and your digital oscilloscope, this is over $100,000 worth of test gear.
Oh yeah,
Easily.
easily. But yeah,
Yeah.
far more than that sitting on this bench because I've got
Yep.
RF test equipment here and stuff, all of which is part of our R&D process. And then there's more of this stuff out in production because every product that goes out the door gets tested fully on audio precision test stations. So there's additional stations out there for testing. So what I'm going to do is I'm going to turn this level up to 100 watts. Okay, so that motorized pot's turning up. I now have 99.77 watts coming out, 0 dB relative to the full rated output. And if you look at the speakers here, we've got, we would have 110 dB, 1 kilohertz tone blasting in this room if I had a set of speakers hooked up. Fortunately, I've got a set of resistors hooked up.
You don't want to sit in that. It's that loud.
and if we had horn speakers, we might have 120 decibel, getting close to the threshold of pain. Especially with a 1 kilohertz tone. So that's sitting there cooking away. And now what I'm going to do is I'm going to mute the signal going to the DAC. And we're going to look at this output level. And what we're going to be measuring is just the noise. Right now we're measuring the, and I lost my mouse. Hang on. Where's my mouse? My mouse is gone. There it is. Okay. All right. Turn the signal off. And the noise level coming out of the amplifier is 122 dB below the peak level. Now that's due to the noise of the DAC. That's the signal to noise ratio of the DAC when it's running at a gain at a volume setting of -2 dB. Just turns out that that's where the DAC needs to be running when it's hooked directly to the power amplifier. And the reason we have it set at -2 dB is we wanted to give you some room to turn the volume up if you've got a weak signal. And it also allows you to overdrive the amplifier slightly. So that's just the way we chose to match the DAC3 to the AHP2.
Right.
So what you're seeing is the signal to noise ratio of the DAC3, not the signal to noise ratio of the amplifier. And we'll see that the amplifier actually has an additional 10 dB of signal to noise ratio, which.
So just so you know, John, your feed is a little distorted. So I'm switching back to the audio precision screen. When you really talk about the numbers, it's much clearer.
Okay. All right. That's fine. What I'm going to do now is I'm going to intentionally misconfigure this system. And the way I'm going to do that is I'm going to increase the gain on the amplifier, and that's going to force me to turn the volume down on the DAC. So first off, before I do that, I'm going to turn the volume down on the DAC and turn the signal back on. And I'm going to increase the gain. Oops, wrong volume. And I'm going to turning the DAC up to get back to 100 watts output.
Yep, you are at 93.8 right now.
Okay, that's as close as I can get because I can only go in half dB steps.
Yeah.
I'm a quarter dB. I'm a quarter dB below full output, and that's 94 watts. So it's the difference between 94 watts and 100 watts sounds like a lot, but it's only 0.3 dB. So keep that in mind when you're looking at wattages. It can be very misleading sometimes.
Mm-hmm.
So anyway, our full signal is again at the same level. I'm going to mute the DAC, and let's see if we get our 122 dB signal to noise ratio. Oh my gosh, what happened?
Looks like 109.
109. Okay, so we lost 13 dB of noise performance because we've got the system misconfigured. Okay, if you look at the position of the volume control on the DAC, you can see that it's turned way down.
Mm-hmm.
Okay, I'm not using the full dynamic range of the DAC. I'm just using the lower portion of it, forcing overuse of the volume control. And that overuse of the volume control has reduced my signal to noise ratio by 13 dB. Well, let's look at whether that's of any consequence. Let's look at the sound pressure level in my listening room. So in the upper right-hand corner, you can see that we're at about 1 dB SPL on my 90 dB speakers. And I'm at about 10 or 11 dB SPL from the high efficiency speakers. So I'm at a point now where if I'm using high efficiency speakers, I may have some audible noise in the room. And that's, it was completely unnecessary. If the system was set up properly, that wouldn't have happened. But the incorrect setup has caused the noise to rise by 13 dB and rise enough that with high efficiency speakers, we can hear noise coming out of the speakers.
Yeah.
Now, if the DAC was not as good as benchmark DAC, that effect would be far worse. And so what we're doing is we're amplifying the output noise of the DAC because of the fact that we've got too much gain in the power amplifier.
So this is when you have the gain set to high on the benchmark
Yes.
amp, right?
Yeah.
Yeah.
Now, just to quickly show the difference, I'm going to mute the audio. It's muted right now. And watch this number, 109. If I go to medium gain, 115.
Yeah, 115, yeah.
And then low gain, 122. And it's not because the amplifier got noisier. If I short the input of the amplifier, all right, there's the signal to noise ratio of the amplifier, 132 at low gain. If I go to medium gain, I lose about a dB.
Mm-hmm.
Okay, I'm running right around 131 in medium gain. And if I go to high gain, the amplifier does about 129 dB signal to noise ratio. So because of the fact that we're increasing the gain of the amplifier, and the input noise of the amplifier, the equivalent input noise becomes a factor. We lose about a dB or two when we go into high gain. So for best performance, you want to be running the amplifier at low gain. And that's consistent with what we're saying here. You always want to have high signal levels as early in the system as possible, and take as little gain as possible in the power amplifier.
Well, it's
Now,
important to note when you set it to the low gain setting, you have to have a preamp that has the appropriate voltage output. So most consumer audio single-ended outputs are 2 volts RMS.
then that's a
Sometimes you get
problem.
up to about, yeah, you might
Yeah,
get 4 volts clean. You might
yeah.
on some consumer audio.
And that's what our mid-gain setting is for. Our mid-gain setting is specifically for the 4-volt equipment. And
Right.
so you put the amplifier in mid-gain position, and it's designed to work with 4-volt signal. Now I'm going to insert the LA4 into the signal chain. Okay. And I'm going to hit the mute button on this. And I want you to see that when the LA4 is muted, again, we're delivering the full 132 dB signal to noise ratio of the amplifier. The LA4 output stage is not adding any noise, any measurable noise to the amplifier. Now, if I turn it on, you're going to see a very familiar number here, minus 122, which again was the output noise of the DAC. Again, with the LA4 inserted, I now have 122 dB signal to noise ratio through my entire chain. So the LA4 didn't add any noise to the system. And the reason it didn't add any noise to the system is because the noise of this device is so much lower than the noise of the DAC that it passes the DAC signal through without adding noise to it. So now, can I use this to improve the performance of the system? And the answer is yes. What I'm going to do is I'm going to disable the volume control in the DAC3. And what that's going to do is it's going to increase the level by 2 dB.
Right.
So it's going to allow me to operate closer to the optimum operating point on the DAC3. So what I'm going to do is press and hold the mute button.
So now it's not a variable output anymore. It's a fixed output. What's the fixed output on it? Is it 4 volts or is it 12?
It's 12.28
12.
volts
Okay.
RMS. So it's 24 dBu. If you want to talk in dBu units that we normally talk in, the units that we normally use with professional audio. But so now that's putting out 24 dBu. I'm taking a 2 dB cut and going into the power amplifier. If I turn my generator on, I've got my 100-watt output, the expected 100-watt output. And now let's see what happens if I turn the generator off. Again, I see the, I've got 122 dB signal to noise ratio. But watch what happens when I turn the volume down on the LA4. You can see that the noise is going down in proportion with the volume setting. As I turn the volume down, the noise goes down as well. And at some point, I reach the minus 132 dB, which is the 132 dB signal to noise ratio of the power amplifier. And so what's happening is I'm turning both the signal and the noise of the DAC3 down when I turn it down with the volume control that's in the LA4. So at all volume settings below maximum, I'm going to end up with a lower output noise than I would if I drove the amplifier directly with the DAC. And
so basically in this case, you had 2 volume controls. You don't want to have 2 volume controls. You want to have the source as a fixed output at the maximum unclipped output. and then you use a one master volume control in the preamp, because the preamp is the lowest noise volume control out of the whole system.
Yeah, and because it's an analog volume control, it's doing two things. It's dropping the signal level and it's dropping the noise level. If I were just using a digital volume control, what you'd see is you'd see the signal go down, but the noise would not change.
Right. Yeah.
Okay, what's happening with this is they're both going down. All right. And if I turn the signal off, and the signal is off right now, and we look over here, we can see that the output noise out of my speakers is minus 20 dB SPL. In other words, it's 20 dB below audibility. And as I turn the LA4 up, we get closer to the performance that we had with the DAC directly connected to the amplifier, minus 12. But you can see that minus 12 number go down as I turn the LA4 down. So we're always getting optimal noise performance through the system when I've got the LA4 in the middle. But now here's the interesting thing. Let's intentionally misconfigure the gain on these two boxes,
right,
and try to fix it with the LA4. And we're going to find out that it actually works wonderfully. So I'm going to turn the gain up on the AHP2. Maximum gain
setting. Okay.
Maximum gain. All right. I'm going to turn the LA4 up until I've got 100 watts. Oops, too far. It's about there.
Close enough.
Close enough. 0 dB. Okay. If I mute my audio, I still have 121 dB of signal to noise ratio. Okay. In spite of a gross misconfiguration, this LA4 took a 16.5 dB cut in level to drop the level before it went into the AHP2. The AHP2's got too much gain, but because of the fact that this is a low noise device, it was able to achieve almost exactly within a half a dB or 3/4 of a dB, the same signal to noise ratio that we would have had in a properly configured system. So this misconfiguration, in our case, it's a misconfiguration, but if you're mixing and matching pro products and consumer products and unbalanced outputs and balanced signals, you've got all these different levels that you're trying to match together. And you may have a power amplifier that's got way too much gain.
Yeah.
And this allows you to match those and optimize it. And the cool thing is that whatever volume setting you're using, the gain staging is optimized for that particular listening level.
Yep. Yeah, and I've run into this, with really high gain power amplifiers, because they're designed to work with AV receivers. I'm talking about amplifiers that have a gain of plus 30 dB or more. You plug them into a high efficient speaker, like let's say a Klipsch, for example, and you can hear the hiss even from a few feet away.
Right.
That drives people nuts, drives me nuts. I don't like hearing background noise. I try to keep my rooms as quiet as possible. And
yeah, we've got quite a few customers that have got they've got the trio horn speakers or some of the other very high efficiency horns. We're talking 105 dB, 109 dB, very high efficiency speakers. And the wonderful thing about this system is it's dead quiet, in spite of the fact that they've got very high efficiency speakers.
So just to recap, what the best settings in this scenario is, you want your DAC on a fixed output, not a variable. So that'll give you the 12.2 volt RMS output out of the DAC.
Yep.
Then you set the amplifier, the HB2, to minimum gain setting, the low
Yep.
voltage gain, which I think you said was what, 6 or 9 dB? Was it 9
It's
dB?
It's 9.2 dB.
Yeah. So 9.2 dB of voltage gain, not to be confused with the current gain of the stage.
Right.
And then you use the master volume of the preamp, which
Yep.
is the lowest noise floor device out of the three,
Yes.
especially because
Yep.
of the analog volume control.
Yeah. So this is the lowest noise device out of the three, the LA4. The second lowest noise device is the power amplifier, and then the DAC is actually higher noise than both of these. Now, there's a reason for that. If you want to be able to deliver the entire signal to noise ratio of the DAC, you have to have at least 6 dB better signal to noise ratio out of the subsequent stages. In fact,
Sure.
if it's only 6 dB better, it's going to degrade the performance of the DAC by 1 dB.
Oh, interesting. Okay.
Yeah, so you've got to be maybe 12 dB better and 12 dB better. You see, we have a 10 dB difference between the signal to noise ratio of the power amplifier and the DAC, and
Now the
that's
preamp doesn't.
not accidental. That
by the-
was the design goal, was to be able to build a power amplifier that would deliver the full performance of the DAC3 converter.
Now the preamp itself doesn't have any DAC in it, or does it have a DAC as well?
No, that's just it's a purely analog
Everything
device.
is analog.
Everything's analog. Everything's
Right.
relay controlled. It's resistor dividers that are controlled by relays.
Now let me ask you this, John. I know it's probably beyond the scope of this, but people will probably wonder. The DAC has a toslink and coax output on it, right?
Input, yeah.
I'm sorry, input. Yeah. So do you have a preference? Do you usually prefer the coax? Is it lower jitter? Is it better performance, or is it not even?
The jitter performance is identical. You'll never have audible jitter-induced sidebands. The jitter-induced sidebands are 135 dB below the level of the signal. So, we're talking about signal to noise ratios that are 122. We're talking about going another 10 or 12 dB below that. That's where your jitter-induced distortion is. That's how low it is. And it's the same whether you're using the USB output or the coaxial output or the optical output. Now, there's differences in terms of transmission distance. If I want to send a signal a long distance, I'm going to want to use the coax. If I only need to go 5 or 10 feet, the optical is going to be fine. If I want to do 192 kilohertz, I probably don't want to try to do that with the optical. It may work, it may not work. It may work with a short optical cable. It may not work with a long optical cable. Some optical transmitters and some optical receivers can handle 192K, some can't, and it's really hit and miss whether or not you can get 192K to work through an optical connection. So if you're going to use higher sample rates, use coaxial. USB also works wonderfully. Problem is you can get into a lot of extra processing sometimes in a computer. You don't always know what's going on inside the computer. There might be a sample rate conversion process coupled with that USB port. You get around those things if you're using ASIO drivers, but if you're using some of the built-in drivers in your computer, you may or may not end up in an exclusive mode. If you're in exclusive mode, then you know, bit for bit, you're getting the proper bits coming out. But the general purpose music players don't take you through a bit transparent path. There's a lot of processing that goes on in a PC or in a Mac. if you're not using ASIO drivers.
Yeah, and then the other thing, if you're using a digital source device like just a CD player, you want to use the digital outputs of that into the DAC, not the analog outputs, because that could be the restricting factor for noise and distortion as well.
Absolutely. I mean, it doesn't do you any good to have an external DAC if you're
Then
if you're
convert
using
it
the
again.
analog. Yeah, if you're
Yeah.
using the analog outputs on your CD player. Huge difference in the performance of an external DAC and the DACs that are built into CD players. Even when they've got the right buzzwords, when they've got the right part numbers, oh, this has a ESS whatever in it.
Yeah,
Well,
9038 Pro.
there's
Yeah.
lots and lots of ways to take that same chip, and I can run the outputs in voltage mode. I can run the outputs in current mode. Vast differences in the performance depending on how I operate that ESS chip. And none of that shows up, when you're reading product literature. But there's big differences in how you implement ESS chips. So pay less attention to the part numbers and more attention to the published specifications.
Yeah, I mean, people could get caught up in which model of DAC it is, but it has nothing. It has poor reflection usually on the implementation.
Yeah,
and that
then, and as we said in our last video, the ability to handle intersample peaks is, I think, a really huge issue that hasn't been well addressed. I mean, it's been ignored by much of the industry. And so
Right.
I'd say if you haven't seen that video, go take a look at it. It's a pretty involved topic, and obviously we can't get into that again here.
No, and we have that. I'll put it in the card so it'll just pop up when we talk about it. I put some links to Benchmark Media Systems in there so you guys could take a look at their products. And also, there's a bunch of app notes. You guys have written lots of really cool app notes. I linked that up in there too. A lot of good educational material from you guys. Appreciate that. So I think the next stream we should talk about cables.
That sounds very cool.
I think you got all this low noise floor devices. What cables are you using to make sure you have the best transfer from A to B to C? And what matters and what doesn't matter in cables? Because that's a hot topic for a lot of people. But we love bringing in the science and bringing the measurements into it.
Yeah, and it's a lot of fun when you start measuring cables and you start seeing the tiny little differences in cables and some of the big differences that just having your gain settings set right make, and some of the big differences that treating your room can make. Obviously, you've got to have the right cables, but if you've got the correct type of cable, the differences can be very, very small. And yet people spend a great deal of money on this cable versus this cable, and there's a lot of disinformation out there. There's a lot of snake oil, and it's really it's a fun topic, but every time we talk about it, we get angry phone calls.
Oh, I'm sure.
Yeah.
We got a question here I think is a good one to wrap this up. So how do you know exactly what amp to buy to match your receiver or processor for home theater and in the same system 2-channel?
Well, what you need to look for is an amplifier that's got low noise and low distortion, and also look for an amplifier that doesn't have too much gain. Don't buy the amplifier that's got the most gain. That's not the parameter that matters. Sometimes people put two things together and they'll look at them and say, oh man, this amplifier's got 35 dB of gain and this one's only got 25. I'm going to buy the one that has 35, when actually you should be buying the one with less gain, not the one with more gain.
Sure. And I like to look at signal to noise ratio on amplifiers, preamps. I like to look at, for amplifiers, I like to look at 1 watt, because if you're comparing amp A to amp B and they're at different power levels and they're rating it at max power, you're not comparing apples to apples. You equalize everything when you compare everything to 1 watt. And then you can calculate what the SNR will be at full rated power.
Yep. It's absolutely what counts is the 1 watt performance. And then at the upper end, does it have enough output power to give me the sound pressure level that I'm going to need in my room? And usually you're listening at 1 to 5 watts, maybe 20 watts if you're really cranking things. But you're not using 400 watts. You're not using 800 watts. If you did, you're melting your voice coils.
Or your ears.
Or your ears.
Yeah. The only thing is the bass takes lots of power.
Yes,
so
yes.
I have a pair
Absolutely.
of speakers.
Yeah, no question there.
I've got a pair of speakers in now from Arundel Sound that are they're a bookshelf. They're the largest bookshelf I've ever seen. The sensitivity on them is 84.5 dB, but they're tuned to 22 hertz, so they will absorb power. And I've clipped Class D amps that linear amps drove better. So that's going to be an interesting topic when I start talking about that on YouTube. You really got to know how that amplifier performs at low impedance, at sustained output when you're dealing with bass.
Yeah.
When you're dealing with speakers that have low sensitivity, that are tuned low to give you the extension.
Mm-hmm.
So, John, I appreciate it. Guys, please check out Benchmark Media Systems. The link's below. And we will be back again in a few weeks. Maybe we'll try to get one in before Christmas. If not, we'll definitely do it before the new year. And let's talk about cables. I think that should be the next topic.
I agree.
All right, guys. Well, that's a wrap. Please hit the thumb up, hit subscribe. Don't forget about our Patreon channel at patreon.com/audiohawks. We appreciate your support. You get direct access to me if you want to suggest video topics. And until next time, my friends, keep listening.